Hi everyone, my name is Ruslan. I am a Revit enthusiast and researcher who is focusing on engineering and calculation. In this video, I will show how electrical load calculations works in Revit. We will start from the moment when electrical equipment, meter boards or RMB, and electrical fixtures, load centers are already placed in the model and appropriate meter boards are assigned to all spaces. The first step is connecting all load centers to RMB according to the space assignment. For example, this unit is assigned RMB 12, and the load center should be connected to the RMB 12. Let's use Dynamo for all routine actions. Run script and check the results. All space assignments we can check visually by the color scheme placed in this space. Green should be 12. All these units should be connected to RMB 12. The situation should be the same from the opposite side. The space color is showing RMB 21 and the load center connected to RMB 21. Everything is okay. Now we see that our load is 0. In the next step, transfer load and unit number from spaces to load centers, also using Dynamo. Run script. Now we see load and unit name according to unit number. And close Dynamo and check results in comparison table. All unit numbers should be the same with consumer tag, and load also should be the same. See that all values match. Next, transfer the unit names to the created circuits and assign load classification for all instances in another comparison table. Close this table and open another table. I will use Dynamo to pass the name. Go to Manage, Dynamo Player, and run script for electrical circuits. Done. We have the same name for fixture and for circuit. To assign the load classification, I will duplicate this table and change sort parameter. none. Now I select from drop-down list residential load center. Done. Now go back to our original table and check result. Everything is up. From this moment we are ready to start to work on the main calculated table. Close the previous table and open new and fill in all required parameters. Accept that all cables to the residential units will be aluminum. To accelerate our work, let's duplicate current table and change sorting parameters. Select none. OK. Now go back to the type and select aluminum, non-magnetic. And material also aluminum. Now go to the sorting again and sort by suggested aluminum size. Go to aluminum and from drop-down list we select suggested size of conductor. As you see, ground conductor calculated automatically. This conductor based on the selected hot conductor. Now select power factor. In this example I will use 80, but you can use any from this drop-down list. Now go back to the original table and check results. Assume that the voltage drop cannot exceed 4% from the source to the load center. This parameter already set in the formatting. Greater than 4. We got the worst case scenario for the most remote units. Now we need to increase the conductor size to adjust the voltage drop. Let's make some improvements. And increase conductor size. If for some reason we cannot adjust the voltage drop value and cannot reduce this value on the RMB, we need to replace aluminum with copper. Now let's do the same for the copper conductor. If copper doesn't help, consider changing the location of the load center or RMB. That's why the preliminary analysis is important to avoid such situation in the final stages of the project. Now replace all values in specially prepared tables for the result presentation and create single-line diagrams for each RMB using Dynamo. I already placed tables and generic annotation families for the single-line diagrams. I will run two scripts to get the final result. Open Dynamo, go to Script, replace RMB parameters, and run. Check results. For MB11, for example, we have 11 units. We got consumer name, demand load, cable, voltage drop, and fault current. Now replace these parameters to single line diagram. Open Dynamo again. Open script and run. Now have replaced parameters, 11 units, first unit 370, 17, and last unit 318. Let's check it. 317 and 340. Repeat this operation for all other meter boards. Finally, we have the full load calculation and single line diagrams directly in Revit without additional software or plugins. We used only Revit standard tools.